Okay, so if you've got the example so far and you've got this one up to number 20, should be pretty easy. They're just straight up and down vectors. You get to pick the most reasonable axis. And now I told you the secret. So then you pick a reasonable axis and you figure it out. All the forces vertically. I think until we get to number 26, we don't have any horizontal forces. There's some in 20, but I'm going to give it away. Okay, so here's the setup for number 20. Okay, up until here, you just pick an axis, you cancel out your forces, you cancel out your torques. If you accidentally flip it anti-math, and because math says counterclockwise angles and therefore torques are positive, and negative angles that turn down like the clock from x from 3 o'clock, those are negative. So if you break the math convention, that's actually fine. It will still work just right, but you have to be consistent. Okay, so maybe we'll keep with it. All right. We have a beam, and there's a sign hanging from the end of the beam. You see these a lot. There's a hinge against the wall. That's where I've marked the axis. That might be a good place to put it for now. Um, and we have a guide wire, it calls. And there's tension on this wire that's the hypotenuse of the triangle. But this is a little bit complicated problem because the wire doesn't attach to the end of the beam. It attaches some distance out that I'm calling R. Right here, they actually give you numbers for all of this stuff. So when you actually do number 20, it should be a little easier than this. This is like the theoretical startup. Now, this is hard, and this is worth me showing. Well, let's circle. Well, let's go red. Because the hinge here is attached to the wall, and it will have some vertical and horizontal force that we don't know at first. So guess what? That's where I'm going to put the axis, right on those unknown forces. So when I start to do the torques and the forces on the beam and the sign and stuff, those all have zero lever arm. Okay, so that's very convenient. So at the first part of the problem, I still have to go back and calculate them later, but at the first part of the problem, I just totally canceled all those forces. Magic, right? With some cleverness, physics can be easy and fun. I just choose an axis so I cancel everything out. Okay, any questions? Anybody need more time to... Okay, some people. This. I just copied the picture from 20 on your homework, and I fudged over the numbers. Okay, oh, the beam itself. I should make this. Sorry. The beam itself has a mass. Let's make this one capital MG. We don't, and you could use weight. It would be more efficient. And then at the center of the beam, we'll make that little mg. The beam itself has a weight, and they just give you numbers for these. Okay, perfect. You need that picture because I'm going to scroll away from it so I can show clear math. Okay. Well, let's start out like we did. Pretty smart. The f of x forces are going to add up to 0, but I'm just going to have the hinge pushing to the right on the beam. So we'll call that plus fx. And then minus the tension force, we'll call that capital T. You could do f sub t if you want. Times cosine of the angle. And that's it. Everything else is pulled straight down or pushed straight up. Blah. But I don't know f of x, and I don't know the tension force. So that's a great equation to keep in your pocket for later. But that doesn't help at all right now. I have two unknowns in one equation. Ugh. Disaster. They tell you the angle from the homework. Okay. Sum of the y forces. Oh my. Let's do on the beam. Okay. There's an Fy from the hinge. Okay. There's a plus T sine theta. The tension pulls up from the rope. But there's minus little mg and there's minus big mg. You can just sum those forces in the problem. Okay, the weight of the sine and the beam itself. Okay, equals 0. That's pretty good. But I still have those two unknown forces. So the torque is going to save us. Okay, this thing also cannot rotate. It can't swing down. It doesn't whip up or anything. As the beam hinges. Okay, we're gonna, yeah. Okay, so remind yourselves, torque is lever arm times force. Okay, hey look, there's an angle between the tension and the lever arm, because tension's up at an angle, but I already accounted for it by doing sine theta. Okay, I immediately split that tension. Does that everybody see that? I split that tension into sine component straight up from the beam and cosine component along the beam, but it points towards the wall. It points left in the picture. Okay. Sum of my torques with math direction equals 0. Okay, so I have minus, oh no, minus length of the beam over 2 times little mg. The center of mass of the beam is at the center, half the length. I have minus length of the beam times big mg, the sine with big M. The sine is heavier than the beam. The sine is hanging off the end. And my only other torque, because I put the axis right on those unknown forces, the only other torque is this distance we're calling r. It gives you a number in the problem. R, because it's a lever arm, is r times t sine theta. And you're given theta, and your only unknown is t, and you're given all these other things. So you can actually solve the torque equation. Oh, I already had it 0. So because we are sure we know how to calculate torques, and this thing doesn't rotate, and it equals 0, total torque equals 0, we can just plug in numbers and calculate the tension right there. Yeah. Capital L is the total length of the beam. Watch out that the wire is attached at some other length that I call little r. Okay, so we set up the torque equation, and oh man, it's one unknown and it equals 0, and I can plug in all those numbers and just solve flat out for the tension. Okay, and then once I have the tension, I can start plugging it back into these other equations. Oh, I know cosine. I can find out f of x right away because I know tension and cosine of 35, or at least your calculator does. Yeah, this book chooses bad angles too. And I have t and sine of theta. Okay, and that equals 0, and so you solve them back that way. Okay, once you know the actual value of the tension from this torque equation, you can plug tension back in and solve for everything that you don't know. So actually, once we see this happening, number 20 is not that hard at all. Okay. Any questions? All right. Let me know if you do have some. The rest of the time is yours. You guys get like half an hour. It's going to take me longer than the other classes. Or, well, they have shorter hours also. Here, let me zoom out, see the whole thing in all its messy glory. Okay. We don't need the very top. Okay, there's everything with all its labels. Attempt up to 20. See if you can finish those first 1, 2, 3, 4, 5 problems today. And then we'll go over the test and maybe start 26 tomorrow. And I'll help with 26 and 27. Because 26, if you're really good at trig, you can do it yourself. 27 is an absolute mess. And we'll probably spend half of Wednesday with me helping. And then I'll finish 27 as best you can.